Happy learning. Have a great day. The universe is the vast expanse of space and all the matter and energy within it. It is believed to have formed around 13.8 billion years ago in an event known as the Big Bang, which marked the beginning of the universe's expansion. The universe is comprised of countless galaxies, each containing billions of stars, planets, and other celestial objects. The observable universe, the portion of the universe that we can detect through electromagnetic radiation, is estimated to be approximately 93 billion light-years in diameter. The universe is also characterized by various fundamental forces and particles, including gravity, electromagnetism, and the strong and weak nuclear forces. These forces and particles interact to create the physical laws that govern the behavior of matter and energy in the universe. Despite ongoing scientific research, there are still many mysteries surrounding the universe. The universe was born with the Big Bang as an unimaginably hot, dense point. When the universe was just 10 to 34 of a second or so old, that is, 100th of a billionth of a trillionth of a trillionth of a second in age, it experienced an incredible burst of expansion known as inflation, in which space itself expanded faster than the speed of light. During this period, the universe doubled in size at least 90 times, going from subatomic size to golf ball sized almost instantaneously. The work that goes into understanding the expanding universe comes from a combination of theoretical physics and direct observations by astronomers. However, in some cases astronomers have not been able to see direct evidence, such as the case of gravitational waves associated with the cosmic microwave background, the leftover radiation from the Big Bang. A preliminary announcement about finding these waves in 2014 was quickly retracted, after astronomers found the signal detected could be explained by dust in the Milky Way. According to NASA, after inflation the growth of the universe continued, but at a slower rate. As space expanded, the universe cooled and matter formed. 1 second after the Big Bang, the universe was filled with neutrons, protons, electrons, anti-electrons, photons and neutrinos. The shape of the universe and whether or not it is finite or infinite in extent depends on the struggle between the rate of its expansion and the pull of gravity. The strength of the pull in question depends in part on the density of the matter in the universe. If the density of the universe exceeds a specific critical value, then the universe is closed, and positive curved, like the surface of a sphere. This means light beams that are initially parallel will converge slowly, eventually cross and return back to their starting point, if the universe lasts long enough. If so, according to NASA, the universe is not infinite but has no end, just as the area on the surface of a sphere is not infinite but has no beginning or end to speak of. The universe will eventually stop expanding and start collapsing in on itself, the so-called Big Crunch. If the density of the universe exactly equals the critical density, then the geometry of the universe is flat, with zero curvature like a sheet of paper, according to NASA. If so, the universe has no bounds and will expand forever, but the rate of expansion will gradually approach zero after an infinite amount of time. Recent measurements suggest that the universe is flat with only a 0.4% margin of error, according to NASA. In the 1920s, astronomer Edwin Hubble discovered the universe was not static. Rather, it was expanding. A find that revealed the universe was apparently born in a Big Bang. After that, it was long thought the gravity of matter in the universe was certain to slow the expansion of the universe. Then, in 1998, the Hubble Space Telescope's observations of very distant supernovae revealed that a long time ago, the universe was expanding more slowly than it is today. In other words, the expansion of the universe was not slowing due to gravity, but instead inexplicably was accelerating. The name for the unknown force driving this accelerating expansion is dark energy, and it remains one of the greatest mysteries in science.